see how this works. Okay, so let's review some physics.
What?
Mhm. Yeah, applications, that's what calculus. Calculus is a tool that Sir Isaac Newton invented to further his studies of physics.
Has a tutor at home.
Okay, if this is the graph of time versus velocity.
Acceleration.
No, maybe. Okay, let's do something like this. Here's
There is
2,
displacement.
here's -2, 1, 2, 3, 4, 5, 6. Okay, what if you have something like this?
Oh, you know what? That's
Did,
Oh, crap.
did. Okay, so on the interval from 0 to 6, I guess it can be seconds or minutes, whatever. What does the area tell you
Displacement.
if this is the velocity? Displacement, the distance traveled, right? So if you come, so the kinds of areas you get in physics are these kinds, right?
Yeah.
The kind you can just use regular geometry for. So like, what would you do? Split it up into a square and a triangle? Okay, so this, or you want to do a trapezoid?
No.
No, I think we do need, because I think
Yes.
tonight's homework a trapezoidal rule again.
Based on these two. Trapezoid.
Okay, so how do you find the area of a trapezoid? 1/2 the height, except, no, the height is this way, times B1 plus B2, 4 plus 2, and if you don't like it, just break it up into a square and a triangle. So the area of this is what?
Yes.
6. Come on, I just did it for you right there. And then this is a triangle, so just go 1/2 base times height, 1. So what if I told you, okay, from 0 to 6, what is the displacement of the particle?
8.
Minus.
No.
6 minus.
This particle, so this means the particle traveled 6 units to the right because the velocity is positive, right?
That's position.
This means the particle traveled 1 unit to the left because the velocity is negative, it's below the x-axis. So think about it. If you traveled 6 units to the right and then 1 unit to the left, aren't you 5 units to the right of where you started?
Distance is. Distance.
So the displacement is 5.
8.
So you guys know what this means, right? You're 5 units to the right of where you started. But then, what if I ask you, what is the total distance that you traveled?
6.
7.
7.
Well, come on, look. If I traveled 6 units to the right and then 1 to the left, 6 plus 1, 7. Right? That's what you did in physics.
Come on.
But do you really think in real life you're just going to get nice, easy geometric shapes like
Course.
this? The answer is no. So, well, do we know how to compute area? Yeah, integral, exactly. So if we integrate the velocity, that will give me the displacement. So the integral of the velocity dt from t1 to t2 is simply the displacement. Right? That's this one here. Because when the graph goes below the x-axis, don't we count that as negative? But what if we want the total distance traveled though? What kind of integral do we need to do? Well, we need to count this one as positive. How would I count this as positive? Well, what thing can I do to a function so that anything below the x-axis gets reflected above?
Absolute value.
Thank you. You integrate from t1 to t2 the absolute value of the velocity. That means this thing under here gets reflected above, and then it's going to be counted positive. So if you just integrate the velocity, you're going to get displacement. If you integrate the absolute value of velocity, you get total distance traveled. Now on the AP exam, I'm going to say 90% of the time, they're going to ask you for total distance traveled. In fact, probably 95% of the time. Only once in a while they ask for this displacement. So that means you have to have that absolute value on there. Now a lot of the integrals you're going to do, you can simply use your calculator, so it's easy. Just make sure you put the absolute value on when they ask you to compute the total distance traveled. However, some of the problems, you're not gonna get a calculator, so that means you're gonna have to do work. So what if I give you a problem like this? Here's the velocity, t minus 1 times t minus 3. Who knows, for the first quiz, I might even give you this exact same problem, because when I sit down and type out a problem, I think of the same things all the time. So, from t equals 0 to t equal 5, compute the displacement. So here, A, compute the displacement. And then part B, compute the total distance traveled. Now, which of these is the easiest? Displacement, exactly, because you don't have to worry about the absolute value. So, to compute displacement, you simply integrate the velocity, which is this, from 0 to 5. Okay, now how do I do this integral? You guys should be experts at this.
Yes.
Multiply it out. Now, should I put the 3 on the outside or keep it in there? Now, see if you can, look, think of the next step.
Keep it in.
How come?
T cubed.
T squared.
Oh, Suzuki! You guys know what he's talking about?
Yeah.
Okay, what happens when you, okay, if you multiply these two, you're gonna get t squared minus 4t plus 3, right? When you distribute the 3, you're gonna get this. Why is it better to have the 3 there? Because the antiderivative of that is just t cubed. Whereas if you put it out there, then the integral will be 1/3 t cubed, you get fractions, but it really doesn't matter. Fractions don't bother the people. So how do we compute integrals? We find the antiderivative, which is t cubed minus, come on, this you can't get easier than this, this is polynomial. 6t squared plus
19.
9t from 0 to 5.
Plug in.
Plug in,
I have a question.
Mhm.
Is 3 not just a constant you can take out?
Yeah, you can, but I'm saying in this problem, it's better to put it in. Because then look, the antiderivative is just t cubed. Whereas you would have a 1/3 out there. But like I said, it doesn't matter. Okay, plug in the top number. 125 minus
150.
150 plus
45.
45 minus 0 plus 0. So what is that going to be? Negative 25 plus 45.
Oh. 20.
Because these two together is negative 25, right? You get 20.
20.
That is your displacement. That means the particle, at the end of the 5 seconds, the particle is 20 units to the right of where you started. So one of the questions on tonight's homework, they're going to tell you if x of 0 is equal to, give me a number,
7.
7. Hey, I was thinking that. Then what is x of 5?
7.
No. Look, after the 5 seconds, the particle is 20 units to the right of where it started.
27.
So if you started at 7, and then you end up 20 units to the right of that, where is that? 27. So you gotta understand what's happening here. Okay, now total distance traveled is actually much tougher because we gotta deal with the absolute value. Hey. Okay, we're gonna need some space here. So what do we know about absolute value? Just pretend it's not there?
Yeah.
No, you gotta think piecewise function.
Oh.
If the inside is positive, you leave it alone. If the inside is negative, you negate it. That's how absolute value works. So to find the total distance traveled, we have to integrate from 0 to 5 the absolute value of the velocity. Now, if you had a calculator, you just punch it in right there with the absolute value signs, and the calculator would just spit out the answer. But if you don't have a calculator, then we gotta make piecewise function. So what you gotta know is, you gotta know when is the velocity positive and when it's negative, so you gotta make a number line. So look at the velocity equation, what makes it 0? 1 and 3, put that on the number line. And come on, we should be good at number lines by now.
Plus, minus, plus.
Plus, minus, plus. You can think of the graph or just plug in numbers, yeah? So that means we gotta make 3 integrals. One integral is gonna go from 0 to 1.
No.
I'm just telling you what you gotta do.
Is it like an?
Then you're gonna have to do another integral from 1 to 3, and then you gotta do another integral from 3 to 5.
No.
I'm just telling you what you gotta do.
Oh, and then you just do it.
Okay, so this is what you do here. I'm gonna show you how you can save time. So 0 to 1 of the velocity dt, then you do another integral from 1 to 3 of the velocity dt, and then you do one from 3 to 5. Okay, but look, we already did some of it already. Isn't this the antiderivative right here?
Yeah.
Yeah, so why not just, instead of doing everything again, why not just use the antiderivative we got already? So it's gonna be t cubed minus 6t squared, oh, why am I going down first? Let's do this one here. T cubed minus 6t squared plus 9t from 0 to 1. Okay, plug in the top number.
1
Minus 0 minus 0 plus 0. And that comes out to 4. Now, what does that mean? From 0 to 1 seconds, the particle traveled 4 units to the right. That's what it means. So wherever the starting place was, it traveled 4 units to the right. That's what happened. Okay, now here, the velocity is negative, so now we're going to compute how far it went to the left. Okay, so again, why reinvent the wheel? We already know the antiderivative. Now we just go from 1 to 3. Plug in the top number.
27.
Minus
54.
54 plus 27 minus, plug in the bottom number.
Oh, wait.
1 minus 6 plus 9, which actually you did up here, right? So, hey, this is 0, Mr. Park. 54 cancels negative 54, so what do we got?
0.
4.
No.
Oh. 4.
Yeah, that's 0, but what about this?
4.
But there's a minus sign in front of it.
Negative 4.
Okay, thank you, negative 4. So that, and the answer should come out negative because the graph is going to be below the x-axis, right? So it better come out negative. If it doesn't come out negative, you did something wrong. So what does that mean? From 1 to 3 seconds, then the particle traveled 4 units to the left. That's what happened. Now we're going to go from 3 to 5. Let's use the same antiderivative. Except now you go from 3 to 5. Okay, plug in the top number.
125.
125 minus 150. Hey, we did this, Mr. Park. Plus 45 minus, plug in the bottom number.
27.
27. Hey, that's this, Mr. Park. That's right. You don't even have to do it if you did it or up here. Anyway, that's 0.
The
20.
20.
Couldn't you just, oh, sorry, you didn't say that?
No?
Couldn't you just say that because the total distance traveled is 20 and 4 and 4 and negative 4 cancel each other out? So you would end up,
Oh, yeah, that's if you know that one, yeah?
yeah.
Yeah, you're right. You can do that if you want. Yeah, you can use anything, as long as it makes sense. Okay, so what does this mean? From 3 to 5 seconds, the particle traveled 20 units to the right. Okay. So, look at the picture. What is the displacement?
20.
20, right? And how did you get that 20? You simply add these numbers up. This plus this plus this is 20. Because doesn't that make sense? Isn't that one of the properties of integrals? The integral from 0 to 5 is equal to the integral from 0 to 1 plus the integral from 1 to 3 plus the integral from 3 to 5, right? Remember the properties of integrals? Yeah, so if you simply add these numbers, that's the displacement. How do you get total distance traveled? Add the absolute value of these numbers up. What is 4 plus 4 plus 20? 28, so the total distance traveled is 28. Or you can look at that picture, right? 4 plus 4 plus 20. So, after you see the whole process, you know what I like to do when I do the problem? I just do this one, and then I can answer both questions. Right? I do the 3 separate integrals. To answer part A, just add these numbers up. To answer part B, add up the absolute value of these numbers. Yeah, but it's up to you. If you wanna treat it as two separate problems, you can do that as well. Yeah,
On a test, if you ask that, do we have to show our work for both?
yeah. No, you gotta show your work though. Like if you just show this, and then you go, this plus this plus this is the answer for A, and then add up the absolute value of these numbers, that's the answer for B.
Oh, you can do it.
Wait, does the absolute value, does it matter at the beginning, or is it only at the end when you're adding the values?
Well, absolute value means any graph that's below the x-axis gets reflected above, right? That's this one right here, right?
Yeah,
So that's why when you reflect it above, this becomes positive.
but it doesn't affect your integral, like compared to that one? Does it?
Well, okay, this integral, if you do this integral like on your calculator, that's your answer. When you integrate the absolute value of the velocity, it will give you total distance traveled.
So it only matters if you're doing it on your calculator?
Well, if you're doing it on your calculator, do not make a number line. Just punch it in exactly like this. You don't have to do any work. You just punch it in with the absolute value, the calculator will spit out 28. And if you don't put the absolute value, the calculator will spit out 20.
I'm saying like, if you have the absolute value, does it change the integral or no?
If the graph goes below the x-axis, and it does, between 1 and 3, it goes below. But if the graph is above the x-axis the whole time, then these two answers can be the same.
It wouldn't change the antiderivative?
No?
Okay.
So if you're saying just those pulses on the plus, then you wanted to show work, or, I mean, you would only show work once, and then you would just be like, oh, the answers would be the same.
So if the velocity never is negative, then the answer for A and B will be the same. Henry?
So like on the test, if you have like the A and the B parts, and we just do all the work for like part B, can we just write, like for this example, like write 20 on part A without showing?
Yeah?
Okay.
Yeah, that's what I would do. Suzuki?
On the test, what's the most amount of integrals you're gonna make us do?
By hand, you mean like this?
Yeah.
One time.
Like one of those. So the
Yeah, this is on the test. This is on the quiz and the test, right here. This is a problem. I'm just gonna change these numbers, like t minus 2, t minus 4
No,
or
like-
something.
Like, would you make our number line like zero? So then we'd have to do like multiple of those steps.
5.
Oh, no. The most I'm gonna make you is 3 separate integrals. Come on, we're AB.
Let's go.
Yeah.
Even in BC, I don't think they do more than 3 either. This is, otherwise it's just too tedious, right? You do more than 3. Okay, so wait, Mr. Park. So, look at what we're doing. Wow, I erased it. I'll erase this one then. So, isn't the velocity a rate already to begin with?
Sure.
Yeah.
So, when you integrate the velocity from whatever, t1 to t2, this is a rate, yeah?
Yeah.
What do you get?
This place.
You get displacement, okay, because what are the units of velocity? Like meters per second, you know,
Yeah,
I guess if
so-
you're working in that. And then what is dt? That's an infinitesimally small unit of time. That's seconds, right? Meters per second times seconds, you end up with meters, right? Which is displacement, right, or distance traveled, right? When somebody asks you, how far did you go? 22 meters. Then that means we can use this not just for this, we can use it for any kind of rate problem.
No.
So here, let me give you an example.
No.
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 What if I told you, okay, I turn on my water hose at home. Water is coming out of the spout at 2 gallons per minute. I leave the hose on for 10 minutes. How much water came out of the hose?
20.
20 gallons, you multiply, right? Rate times time equals amount, right? So minutes cancel out and you get 20 gallons. But in real life, when you turn on a spout, or is the water gonna come out exactly 2 gallons per minute?
Yes.
No, because at the very beginning when you turn it on, right, it's gonna come out a little bit, then it's gonna come out. And then what if somebody starts showering? Then the water pressure is gonna go down, right? So in real life, you're never gonna have just a constant rate, yeah? That's why we have calculus. So, What if I said that the rate at which water is coming out of a spout is, okay, let me think of something. Woo! No. Who knows, this might be the same thing as the homework. Wait, I'm trying to concentrate here. Cube root 3t squared plus 1. No, square root. Shh. Okay, here. This is the rate at which water is coming out of a spout, whatever. From t equals 0 to t equal 4 minutes, if t is measured in minutes, how much water came out of the spout? So, wait a minute, sorry. I'm gonna put a t here, otherwise no can do. Okay, so how much water came out of the spout? So if you are given a rate to figure out how much was done, basically you just do an integral from 0 to 4. Because if you look at the dimensional analysis, what are the units for rate? Gallons per minute. This is a time, infinitesimal unit of time. Minutes. What is gallons per minute times minute? Minutes cancel, you get gallons. So anytime you're given a rate, and it doesn't matter what kind, it can be any kind of rate. Like on the AP exam they have, people are going onto an elevator at a rate of something. How many people went onto the escalator? You do an integral, that's what you do. So anytime you're given a rate to find out how much was done or accumulated, you simply do an integral. So for this particular problem, we're going to integrate from 0 to 4. This is the rate. This will tell you how much water came out of the spout. Okay, now, next question. Can I do this integral? Now, some of the problems on tonight's homework, they're going to tell you, use your calculator because you can't integrate it. It's just too difficult. But then the ones without a calculator, like the ones I'll make, you should be able to do it. So remember, when you look at an integral, the first thing you got to ask yourself, is it on the list?
No.
Is that on the list?
No.
Second thing, can I do U substitution?
Yes.
Yes. And then last resort for AB, last resort is, can I do integration by parts?
What is that?
Which include, that's the thing we just learned. You just took a test on it. Or can I do tabular?
Oh,
Sure.
no.
Okay, but see, if you were in BC, then you're not, you would have to learn trig substitution and partial fractions as well.
No.
But we're not BC, so. Okay, so everybody said we can do U substitution of this?
Yes.
Okay, so U equals what? du equals 6t dt. See, it's going to work because it's got t dt, right? So this becomes square root of u, that's what this is. And what is t dt? 1/6 du. And what are your new limits? Don't forget to change the limits now. If I plug in 0 here, what do you get?
1.
If I plug in 4 here,
49.
ooh, see? Nice, huh? Okay, what is the antiderivative of u to the half?
2/3.
This is u to the half. Make the power 1 bigger, put the reciprocal in the front, and then don't forget we got the 1/6 there as well. From 1 to 49, okay, can you guys handle that?
No.
2 goes into 6 3 times, so we go 1, 9. Okay, plug in the top number. What is 49 to the 3/2 power? Square root it first,
7.
and then cube it.
49 times 7.
2.
Whatever
No.
49.
289.
No.
Oh, wait.
Okay, just go off on the side. 49 times 7. 3 carries 6. 343. That number doesn't sound familiar?
Oh, I memorized this back in the.
Yeah, I thought when you come out of
You
elementary
did
school,
memorize it.
you know all your square numbers up to 25 and all your cube numbers up to 10.
Yeah.
Can't you just do 7 times 4?
Okay, never mind, just do this then. Minus, plug in the bottom number.
Oh,
1.
1. So 342 over 9. How do I know 9 can go into 342?
because it adds.
How do you know if a number is divisible by 9?
Add up together.
You add up the digits.
What?
What?
Yeah. you-
Come on, this is kindergarten.
That's crazy.
Oh, yeah,
You
yeah.
go 1 plus 2 is 9.
Whoa.
So if you add up the digits and it's divisible by 9, then that number is divisible by 9.
That's crazy.
Add the digits up.
Okay, so anyway, 342 divided by 9. Well, at least you learned it sometime.
3.
9 goes into that 3
Three.
times, 27, so 7 remainder.
8.
38, hey, that's a nice answer, man.
Yeah.
So that means after the 4 minutes, 38 gallons came out of the hose.
Perfect.
Wow.
That's perfect.
Oh,
That's really nice.
oh. Are we gonna get marked off for units? Or what? Or no?
Okay, there's only one problem on the AP exam where they ask for limits as related rates. Remember that?
No.
Oh, I know. It's the square.
Water is draining from a tank at a certain rate. Remember the tank like that?
Oh,
Yeah,
V
it's called
dot,
tank.
V dot thing. Right.
No, similar.
Yeah, the
pattern.
dot,
Oh,
yeah. That's the only problem, you gotta put units. Okay, so here, so once I introduce this to you, so if you're given a rate, how do you know how much was done? Okay, so this is the kind of problem you're gonna see on the AP exam. So sometimes they have people, sometimes they have water. I remember they had like trash. They had rocks. They just make this problem, it's just different every year, but it's the same problem. Okay, so let's say you start with something. In fact, let's do, I remember amusement park ride had this. Okay, whatever, it really doesn't matter. Okay, so I'm trying to figure out which one is the better. Let's just do water, okay? So water is in a tank like this, okay? So in the tank, it starts with a certain amount, so this is the amount of water in the tank. So it starts with something, so the tank is, let's say there's 40 gallons in the tank. Okay? And then they're gonna say, there's a pipe that's putting in water at a certain rate. Okay, and they're gonna say something like, well, from 0 to 10 minutes, how much water is in the tank? They're gonna ask you something like that. Okay, well, it started with 40 gallons. Now, if this is the rate at which water is going into the tank, then how much water went in the tank? What did we just learn?
Integrate.
If you're given a rate, if you do an integral, that'll tell you how much you got, right? How much was accumulated. But then they're gonna say, there's another valve over here where the water is coming out of the tank. So it's coming out of the tank at this rate. So if this is the rate at which water is coming out of the tank, then what? How much water came out?
Subtract.
Minus.
You do an integral, except you gotta subtract it, right? This is how much water is in the tank at the end of 10 minutes. This is understandable, right?
Yeah.
How much you start with, how much was added in, and then how much was taken out. So if you're given a rate to find out how much was done or accumulated, you do an integral. And it's the same problem every single year, like I just said. Certain number of people are in line for an amusement park ride, then people start adding to the line. But then people are getting onto the ride, so they get out of the line, right? So how many people are in the line at the end of the day, or something like that? So, yeah, so this problem's gonna show up on your homework tonight. So just make sure, use your calculator when it says to, because that means the integral is undoable. The only way you can do it is by your calculator. All right, any questions on that? Whew. All right, we've got 10 minutes left. Maybe you should try one problem. Or maybe not. All right, I'm gonna start uploading.
Yeah.